Hello, this is part 2 of cryptography. In part 1, we discussed about how cryptography started. We also discussed about encryption and decryption. If you didn't watch part 1, I strongly recommend to watch that before watching part 2. I'll put the link of part 1 below this video. Today, we will talk more about encryption and decryption, and also some hands-on exercise how to do encryption and decryption using simple C# console application. But first, what are the benefits of cryptography? Confidentiality. The message should be extracted only by an authorized recipient from its encrypted form. If an authorized user can decrypt the message, then confidentiality of the message is compromised. In part 1 of the video, we talked about encryption and decryption. These are two methods that will help us maintain confidentiality by hiding the information, that the message that we are sending between two parties. The second advantage of cryptography is integrity. This helps us determine if the message is altered or changed. If any of the content of the message changed or altered, then integrity of the message is compromised. The third advantage of cryptography is authentication. The recipient should be able to verify from the message the identity of the sender. That is, the recipient should know who the sender and authenticate the sender to send the message. We need to know who is sending the message to us. If we cannot know, that means we don't have trust, or we don't know who is sending that message. The last one is non-repudiation. If I am sending a message to a friend or to a second person, after I send the message, I cannot deny that I sent the message. That's called non-repudiation. We need to make sure that we use cryptography to achieve that. Now to the demo. Here, I created a class using some C# application, console application. This class has two methods, encrypt and decrypt. The encrypt method will take the input as a text and then give back the result as base 64 string. That's not readable because it will be encoded using this algorithm. Now, the second part is the decrypt method, which is the reverse process, which does the reverse process. Right? To achieve these two things, I need two things here. One, the key, it's called a symmetric key, a key that is known by the sender and the receiver. If I'm using this key, the receiver who is going to get that message should also know this key. The IV is nothing but its initialization vector, which is added to add more randomness to the key so that it's not going to be easy to guess or to estimate the key. Okay, now let's run this code. This is a simple Windows Form application. It has two buttons, encrypt using symmetric key and decrypt using symmetric key. Okay, now this is a text box here that I will just type a text in here. So then use these two buttons to encrypt and decrypt it. Okay, let's say I am going to next week, and please keep this information to yourself. Meet me at this address on this time. Thanks. Okay, I have this message. So I want to encrypt it. When I use this one, it encrypts using this key, and it gives me this base64 text, which is not readable, or it's not plain text, and I cannot understand what it says. If I click this decrypt using symmetric key, it will do the reverse process and it's showing me back the plain text I typed originally. I hope you enjoyed this video and find it useful. Until next time, be good, do well, and keep learning. Thanks.